For this video, we're looking for oblique or slant asymptotes. And as you read in your notes, it says that if in a rational function, so we have a polynomial divided by a polynomial with no common factors, if the greatest power of x in the numerator is one more than in the denominator, the function will have a slant asymptote. So if we look at f of x, we have f of x equals x squared minus 2x plus 4 divided by the quantity x minus 2. The first thing I'm looking for is, are there any common factors? And if I look at x squared minus 2x plus 4, I can't actually factor that. So there are no common factors. If I look at the power of x in my numerator, it's an x squared. Power of x in my denominator, it's an x. There's a difference of 1. The numerator is 1 greater than the denominator, so this one will have an oblique asymptote. Now to find it, we're actually just going to do what the problem says. This is x squared minus 2x plus 4 divided by x minus 2. So we're going to perform the division. So I look at my first term of each, and x goes into x squared, x times. Then I multiply x squared minus 2x. Going to subtract, so I'll change the signs. They both cancel out, and that gives me a remainder of 4. Now, if this had been the common factor, then this would basically mean that I get a remainder of 0, and there wouldn't be an asymptote. So you need to check for factors first. So f of x can also be written as x plus 4 divided by x minus 2. So look at what I did. If we took a number like 7/3 and I did the long division, 3 goes into 7 twice, multiply down, subtract, a remainder of 1. This is 2 plus 1/3. 7/3. 2 times 3 is 6, plus 1 is 7/3. Whole number goes right here. Your remainder goes over what you're dividing by. So whole number piece, remainder over what you're dividing by. So I'm looking at this now, and what it looks like is that if I did the limit, and we'll just do in the positive direction of this, this is going to be an infinity, and this is actually going to head towards 0. Infinity minus 2 is something really large. 4 divided by something huge is small. This heads towards 0. So let's say that we're only 100 out. This would be 100 plus 4 over 98. So this is going to keep getting bigger, but you're following this line, the y equals x line. This represents the distance, it's this little remaining part, the distance between your function and the asymptote itself. So my asymptote will always be given by the whole number piece, and this will be the distance between the two, so we ignore that when we're writing the equation, but it does have a meaning. It is the distance between your function and the asymptote. So the equation of the oblique asymptote or slant asymptote is y equals x for this problem. Now if I look at this problem down here, the power in my numerator is 1 greater than the highest power in my denominator. I have an x cubed over an x squared, but I need to check for common factors. And the first thing I notice is that I can pull an x out of everything. So I'm going to factor out an x. I'm left with x squared minus 4x plus 4. And in my denominator I have x times x minus 2. This numerator can be factored. So this is really an x times x minus 2 times x minus 2 over an x times x minus 2. And this is my g of x in the factored form. Well, if I look at this problem now, I actually have some factors that cancel out. My x's cancel out, which tells me that x equals 0 is removable. And x minus 2 cancels out, which means x equals 2 is another removable discontinuity. So what my graph actually looks like is y equals x minus 2 with 2 removable discontinuities, which means there is no slant asymptote. I have nothing left in my denominator. there has to be a rational part in your denominator, an x cubed divided by an x squared, an x to the fourth divided by an x to the third, at the end after you've gotten rid of all your common factors. So a quick graph of this, it's going to look like y equals x minus 2, but I have a removable discontinuity here, and then I'll have a removable discontinuity here. So no asymptote at all, and that can happen, so no oblique asymptotes.